The universe is vast, almost incomprehensibly vast. For centuries, humanity has looked up at the night sky, tracing constellations, measuring the movements of planets, wondering what lies beyond the faint points of light scattered across the cosmic canvas. And yet, despite every telescope, every probe, every calculation, the universe remained mostly a mystery. Until now. The James Webb Space Telescope, a pinnacle of human ingenuity, has opened a new window so precise, that it allows us to peer further into the cosmos than we have ever dared before. In this moment, we stand on the edge of discovery, staring into the very beginnings of time, into the light of galaxies that existed billions of years ago, long before Earth itself was born. What makes the James Webb Telescope remarkable is not just its size or its mirrors, though they are extraordinary. It is the vision it embodies, the audacious human desire to reach beyond our immediate perception, to capture photons that have traveled across cosmic expanses for eons. These are not just images or data points. They are whispers from the early universe, messages sent across billions of years, waiting for us to finally listen. And when we do, we confront the tension between what we can measure and what we can imagine, between the certainty of scientific instrumentation and the boundless reach of human curiosity. Imagine the cold precision of the telescope, its gold-coated mirrors, engineered to near perfection, unfolding in the silent vacuum of space. Its sensors tuned to detect the faintest glimmers of infrared light, invisible to the naked eye. Contrast this with the warmth of human imagination, with the questions that have haunted us since the first time we looked up and wondered, where did we come from? Are we alone? What is the nature of reality itself? In this juxtaposition, we see the essence of exploration, not merely the pursuit of knowledge, but the pursuit of meaning, the desire to situate ourselves within the vast narrative of the cosmos. The first images from the telescope are already unsettling in their beauty. Galaxies forming earlier than theory predicted. Structures in space that defy conventional understanding. Light that has traveled so far and for so long that it challenges our very conception of time. And in these revelations, there is both evidence and mystery, a duality that defines the human relationship with the unknown. We are explorers, yet we are also witnesses, observers of phenomena that stretch our comprehension, testing the limits of both our science and our imagination. There is a profound contrast inherent in looking so deeply into space. On one hand, we have the cold, hard data. Photons measured, spectra analyzed, redshifts calculated with mathematical precision. On the other hand, we have the philosophical weight of these observations, the unsettling possibility that the universe is far older, stranger, and more intricate than we ever imagined. The further Webb peers, the more questions arise. Each revelation carries a paradox. The more we know, the more we realize how little we understand. This is not failure. It is the very essence of exploration. It is the confrontation with cosmic humility, the acknowledgement that our place in the universe is simultaneously insignificant and profoundly meaningful. Consider, for a moment, the light we are seeing. Some of it has traveled for nearly 14 billion years, passing through voids, bending around massive structures, surviving the chaos of cosmic evolution. And yet, it arrives at Webb sensors intact, ready to tell its story. In that journey, there is a metaphor for human understanding itself, ideas and insights traveling across time, sometimes distorted, sometimes hidden, but always offering the chance of revelation. Every photon carries with it a fragment of cosmic history, a story written before Earth existed, a narrative that challenges the assumption that we are the central actors in a linear, easily comprehensible universe. In contemplating these images, we confront the ultimate contrast, the intimate and the infinite. The telescope itself is a small, fragile construct, a testament to human craftsmanship. The universe it surveys is immense beyond measure, its scale almost impossible to internalize. And yet, in this small device, we have a bridge. Through its instruments, we reach out to the cosmos and, in turn, reach deeper into ourselves. There is a poetic symmetry here. The tools of science cold and precise, enabling encounters with mystery that touch the soul. We are reminded that curiosity is not merely about acquiring facts, but about expanding the scope of experience, challenging the boundaries of what we think is possible. The act of observation itself becomes a philosophical meditation. By looking outward, we reflect inward. Each galaxy, each star, each faint smear of light is a mirror, reflecting questions about our own existence. Are we alone? Was life inevitable or rare? Do we occupy a privileged position, or are we an incidental spark in a vast, indifferent cosmos? The James Webb Telescope does not answer these questions directly, but it magnifies them, forcing us to grapple with uncertainty. And in that uncertainty lies a unique form of wonder, a cinematic awe that engages both the intellect and the imagination. Yet, it is not enough to merely observe. The significance of Webb's discoveries is not contained in the telescope itself, but in the interpretive act of humanity. What we choose to see, how we contextualize these findings, how we weave them into our understanding of the cosmos, all shape the narrative of existence. Science provides the language, but imagination provides the meaning. And in this tension, between empirical rigor and speculative contemplation, lies the cinematic thrill of cosmic discovery. We are not just passive viewers. We are participants in an unfolding story, one that spans epochs, galaxies, and the very origins of matter itself. The first moments of exploration have already challenged conventional thinking. Galaxies that should have been immature appear astonishingly developed. Patterns emerge that hint at structures and processes not fully understood. And yet, these anomalies are not inconsistencies to fear. They are invitations. Invitations to question, to hypothesize, to dream. Contrast this with the human desire for neat answers and closure. The universe does not yield easily to certainty. It is a paradox, a place where the known and unknown coexist, where every answer births new questions, and where the awe of discovery is inseparable from the humility of ignorance. As the telescope gazes deeper, the narrative begins to unfold in ways that challenge not only astrophysics, but philosophy itself. Concepts of time, space, and causality are refracted through the lens of data and observation. What is the nature of beginnings? Can we truly observe the first stars, or does every act of observation retroactively define the parameters of reality? Here, science and speculation dance together, each informing the other. The pursuit of knowledge becomes an act of imagination tempered by evidence, and the universe, in turn, becomes both a laboratory and a canvas. In this cinematic journey, the James Webb Telescope serves as both protagonist and guide. It carries the authority of human ingenuity, while simultaneously invoking a sense of childlike wonder. It reminds us that exploration is not merely a technical endeavor, but a narrative of aspiration and courage. To look so far is to confront our own limitations, yet also to affirm the extraordinary capabilities of human intellect and imagination. The telescope is a lens through which we glimpse the unknown, and through that glimpse, we are reminded of the grandeur, mystery, and sheer scale of existence. Finally, as we conclude this opening section, the stage is set. The telescope has unveiled a universe more complex, more beautiful, and more enigmatic than anticipated. But this is only the beginning. We are about to journey deeper, not just into space, but into the heart of cosmic understanding itself, navigating the delicate balance between observation and speculation, evidence and wonder, science and philosophy. The universe beckons, and the James Webb Telescope has given us the eyes to answer that call. What we discover next will challenge assumptions, ignite curiosity, and perhaps, in the process, illuminate what it truly means to be a conscious observer in a universe of infinite possibilities dotted in the vast expanse of space. Human observation has always been constrained by the limits of our technology. From Galileo's first trembling lens to Hubble's orbiting eye, each generation of telescopes expanded our vision a little further, revealing galaxies, nebulae, and star clusters with unprecedented clarity. Yet even Hubble, magnificent as it was, could only glimpse fragments of the universe's infancy. The cosmos, it seemed, had secrets just beyond our reach. Then came the James Webb Space Telescope, a monumental leap not just in size, but in ambition, precision, and imagination. It is not merely a telescope. It is a time machine, a bridge to the earliest chapters of cosmic history, and a testament to the heights human ingenuity can achieve when science and imagination unite. At first glance, Webb is an engineering marvel almost too complex to comprehend. Its mirror, spanning more than 6.5 meters, dwarfs Hubble's 2.4-meter lens, yet it must maintain absolute precision, bending less than a fraction of a human hair under the extreme conditions of space. The mirrors are coated with a thin layer of gold, chosen for its ability to reflect infrared light with minimal loss. Why infrared? Because the universe is redshifted. The light from the earliest stars and galaxies has been stretched across billions of years, moving into longer wavelengths. To capture these ancient signals, humanity required a sensor sensitive to this hidden spectrum, capable of seeing what no eye or previous instrument could detect. Here, science meets necessity, and necessity is answered by vision, an audacious pursuit to see the universe not as it is now, but as it was in its infancy. Deploying Webb into space was itself an epic feat of precision and patience. Unlike any telescope before it, Webb could not simply be launched and pointed at the sky. Its massive sun shield, a 5-layer kite of ultra-thin material, unfolded like origami in the void, designed to block heat and light from the sun, earth, and moon. Without it, the delicate infrared sensors would be overwhelmed. The deployment sequence alone was a ballet of engineering perfection, involving hundreds of hinges, motors, and carefully timed commands. One misstep, and billions of dollars and decades of effort could have been lost in an instant. Yet the successful deployment transformed Webb into a sentinel, poised at the second Lagrange point, nearly 1.5 million kilometers from Earth, in a position of near-perfect cosmic observation. It is a monument to human patience, skill, and daring. Contrast this precision with the early telescopes of history. Galileo peered through a crude lens and glimpsed moons orbiting Jupiter, igniting a revolution. Hubble delivered breathtaking images of star nurseries and distant galaxies, bringing the universe into sharper focus than ever before. Yet both were bound by the limitations of visible light, by atmospheric distortion, and by the fundamental immensity of space. Webb does not merely expand upon these predecessors. It redefines what is possible. It sees through cosmic dust, penetrating the opaque veils that shrouded the birth of stars and galaxies. It reveals structures hidden from previous instruments, galaxies forming when the universe was only a few 100 million years old, and star clusters that challenge our understanding of cosmic evolution. In its precision, there's both clarity and revelation, a reminder that human ingenuity can surpass the constraints imposed by nature itself. The telescope's scientific instruments are marvels in their own right. The near-infrared camera, or NIRCam, can detect the faintest glimmers of ancient starlight, enabling astronomers to study the earliest galaxies in exquisite detail. The near-infrared spectrograph, NIRSpec, allows researchers to dissect light into its constituent wavelengths, revealing the chemical composition, temperature, and motion of distant celestial bodies. The mid-infrared instrument MIRI peaks even deeper, capable of detecting the faint warmth of forming planets and distant cosmic dust. Together, these instruments form an orchestra of observation, each component tuned to capture aspects of the universe invisible to previous generations. They are tools of both precision and imagination, instruments that allow us to move beyond speculation and into empirical discovery. Yet for all its rigor and engineering, Webb is not devoid of poetic wonder. Consider the metaphor embedded in its design, a telescope that unfolds in layers, like the petals of a cosmic flower, reaching toward the universe not with brute force, but with delicate grace. Each component, meticulously engineered, reflects the synthesis of logic and artistry. And this is the essence of Webb itself, a convergence of mind and spirit, of calculation and aspiration, of science and human longing. It embodies the paradox of exploration, rigorous, precise, exacting, and yet profoundly imaginative, evoking awe even as it measures the minutiae of cosmic light. The contrast between what Webb is capable of observing and what we previously believed possible cannot be overstated. Galaxies forming far earlier than predicted, stars burning with unexpected intensity, structures in the cosmic web that challenge the assumptions of conventional cosmology. All of these discoveries underscore a fundamental truth. The universe is more intricate, more complex, and stranger than our models have allowed. Science provides the foundation, the methodology, and the analytical framework. But what Webb sees pushes at the boundaries of comprehension, nudging speculation and wonder into the same orbit as measurement. In observing the universe, we confront not only its scale and age, but the limits of our own understanding. The telescope also embodies the collaborative spirit of human endeavor. It is not the product of a single mind, but of thousands of scientists, engineers, programmers, and visionaries from across the globe. Each mirror segment, each sensor, each carefully coded instruction is a testament to decades of dedication. Contrast this collaborative triumph with the solitary image of early astronomers, working with hand-ground lenses and crude instruments, painstakingly charting the heavens with limited understanding. Webb is a beacon of what humanity can achieve when intellect, imagination, and purpose converge on a singular goal to see further, deeper, and more clearly than ever before. And yet, even as we celebrate the technical marvel, we must acknowledge the subtle tension inherent in this pursuit. With every breakthrough comes uncertainty. Webb sees phenomena that challenge existing theories, galaxies that appear fully formed far earlier than expected, star clusters with unexpected mass, and cosmic structures that seem to defy the slow, methodical predictions of standard models. Here lies the paradox of exploration. The more we refine our instruments and expand our observational reach, the more the universe reveals its complexity, forcing us to reconsider assumptions we once held as foundational. In this tension between expectation and revelation, science meets its poetic counterpart, speculation. Evidence and wonder coexist, each informing the other in an endless dance that the technological achievements of Webb are not merely a triumph of optics and engineering. They are a doorway to new philosophical considerations. By observing galaxies billions of light years away, we are not only seeing distant objects, but glimpsing epochs of cosmic history that predate Earth itself. We are confronted with the enormity of time, the interconnectedness of matter, and the contingency of our own existence. The telescope measures light, yes, but it also illuminates questions about causality, presence, and perspective. It is a bridge between the empirical and the existential, a reminder that our tools shape not only what we can see, but also how we interpret the very nature of reality. As we approach the threshold of Webb's discoveries, one cannot help but sense the cinematic tension in the unfolding narrative. The telescope is more than a machine. It is a storyteller, revealing chapters of the universe that have been hidden for eons. Yet, with every new image and spectrum, it also hints at what we have yet to understand. The light it captures may challenge our theories of galactic formation, the distribution of matter, or even the fundamental laws of physics. In this delicate balance between precision and mystery, the audience is drawn into a journey that is both scientific and philosophical, both informative and profoundly moving. Ultimately, the James Webb Space Telescope is not simply a tool for observation. It is a paradigm shift. It redefines the limits of vision, both literally and metaphorically. It transforms the act of looking into an act of discovery that engages intellect, imagination, and wonder simultaneously. Through its lenses, humanity glimpses the early universe, but in doing so, it also glimpses itself, its ingenuity, its curiosity, and its unyielding drive to understand. And as we transition from this exploration of instrument and vision, we move naturally toward the revelations Webb has already begun to unveil cosmic truths that challenge what we thought we knew, inviting speculation, awe, and the endless pursuit of understanding. The stage is set. We have seen the genius of human engineering, the precision of technological marvels, and the capacity of the telescope to capture ancient light. Now comes the deeper journey into the universe itself, into galaxies forming in the earliest epochs, into the mysteries that defy prediction and expectation. What Webb sees may astonish us, but more importantly, it may transform our understanding of existence itself. The instrument has redefined vision, and the cosmos is ready to reveal its secrets. Time, as we perceive it, is linear, steady, and unyielding. Yet the universe has a different rhythm, one that stretches across billions of years, where light itself becomes a messenger from the past. Every photon that reaches the James Webb Space Telescope carries with it a story, a journey through time and space that began when the universe was in its infancy. To peer through Webb's lenses is to look back to a period when the first galaxies were taking shape, when matter and energy danced in nascent patterns, and the cosmic canvas was being painted for the first time. Here, the telescope does more than observe it, reconstructs the early universe, allowing us to witness epochs that predate Earth, humanity, and all we consider familiar. The light captured by Webb is not merely light. It is a historical archive. Stretched by the expansion of space itself, it has traveled for over 13 billion years, traversing voids and bending around gravity wells, until it finally reaches Webb's infrared sensors. What appears as faint glimmers in the telescope's data is, in fact, the echo of creation. Signals from galaxies that existed when the universe was less than a tenth of its current age. Contrast this precision, this meticulous measurement, with the awe it evokes. What we quantify in photons and wavelengths cannot fully capture the wonder of witnessing the birth of stars and galaxies, of seeing the universe in its earliest moments. There is a tension here between data and poetry, between the analytical rigor of astronomy and the existential astonishment of observation. Astronomers, with their charts and models, often debate the criteria for identifying first galaxies. What does it mean to be a primordial galaxy? Is it determined by mass, luminosity, or chemical composition? Webb's observations have complicated these definitions. Galaxies appear more mature, more structured, and in some cases, more massive than current theories predicted. Some ancient star clusters are already forming at scales that challenge the conventional timeline of cosmic evolution. These anomalies force scientists to reconsider the narrative of the early universe, reminding us that the cosmos does not conform to our expectations, and that every discovery is both an answer and a question. Evidence and speculation entwine here, illustrating the dynamic dialogue between observation and interpretation. Imagine a galaxy forming a mere 200 million years after the Big Bang. Its stars ignite in bursts of energy, lighting up clouds of primordial gas. Webb captures this moment with such clarity that scientists can measure the properties of individual stars, assess their chemical compositions, and infer the conditions of the early universe. Yet, while the measurements are precise, the experience transcends calculation. There is a poetic resonance in knowing that we are witnessing the dawn of galactic history, a reminder of how small and ephemeral human existence is against the immensity of cosmic time. Data alone cannot convey the feeling of standing on the edge of creation, of observing the universe as it once was, raw and unrefined. Webb also challenges our understanding of cosmic infancy by revealing structures that are unexpectedly complex. Galaxies that should be irregular and diffuse appear surprisingly organized, with discernible spiral arms and dense cores. Star formation is occurring at a rate that contradicts previous models. These revelations create a tension between the known and the unknown. The rigor of astrophysics confronts the mystery of a universe that is far stranger than predicted. Contrast the certainty of redshift calculations, spectroanalysis, and luminosity measurements with the imaginative possibilities these anomalies suggest. Could our theories of cosmic evolution be incomplete? Might there be mechanisms of galaxy formation that we have yet to comprehend? Science provides tools, but it cannot answer all questions, leaving space for speculation and wonder. The telescope's power to probe ancient light also reframes our conception of time. When we observe distant galaxies, we are looking into a past that no human could have witnessed directly. The further we look, the closer we approach the universe's origins. This is not merely observation. It is time travel in its purest form, a reconstruction of events that shaped all that exists today. Contrast this with our daily perception of time, so limited and immediate. Through Webb, the universe communicates in eons, reminding us that our existence is but a fleeting moment in a narrative billions of years in the making. And yet, within this vast temporal framework, humanity gains perspective not in significance alone, but in awareness of our capacity to understand, to measure, and to wonder. There are debates within the astronomical community about how to classify the earliest structures Webb has observed. Some researchers argue that the first galaxies may have been small, irregular aggregations of stars, forming in chaotic clusters that gradually merged. Others suggest that massive luminous galaxies could have arisen earlier than expected, implying that cosmic evolution occurred at a faster pace in certain regions. These discussions reveal the interplay between observation and theory. Webb's data provide clarity, yet also provoke ambiguity, illustrating the complex dialogue between what is measurable and what is hypothesized. Evidence and mystery are inseparable in the exploration of the ancient universe, and each new observation reshapes the intellectual landscape of cosmology. The poetic dimension of this exploration cannot be understated. When we consider that light from these distant galaxies has been traveling for billions of years, we recognize that we are, in a sense, conversing with the past. Every photon is a message from a time before Earth, before the sun, before even the earliest precursors of life. There is a profound contrast here between human temporality and cosmic temporality. Our lifespans are fleeting. Our civilizations rise and fall in mere centuries, yet the universe unfolds over billions of years. In this tension lies the cinematic beauty of discovery, the understanding that our gaze into the past is both empirical and existential, a fusion of measurement and meditation. Webb's revelations also invite speculation about the conditions that allowed the universe to evolve into what we observe today. By analyzing the composition of early galaxies, scientists can infer the processes of star formation, supernova explosions, and the creation of heavier elements. These processes laid the foundation for planets, chemistry, and ultimately, life itself. Contrast this with the mystery that remains. While we can trace the material origins of life, we still grapple with profound questions about consciousness, emergence, and the conditions required for intelligence. Webb's observations bridge these domains, linking the empirical history of the cosmos to the philosophical questions of existence, demonstrating that science and speculation are not adversaries, but partners in the quest for understanding. The telescope also illuminates the diversity of cosmic structures. Some galaxies appear as faint smudges, irregular and chaotic, while others are luminous, tightly bound, and surprisingly mature. This variation hints at the complexity of the early universe, suggesting that formation processes were not uniform, but influenced by local environments, interactions, and perhaps unknown mechanisms. Contrast the precision of Webb's instruments with the unpredictability of these formations. While we can measure luminosity, redshift, and composition with exacting accuracy, the universe refuses to be fully categorized, reminding us that observation is a dialogue, not a declaration. Each measurement is a prompt to wonder, each image a canvas for both science and imagination. One of the most profound aspects of peering into the ancient universe is the philosophical reflection it provokes. To witness galaxies forming nearly 13 billion years ago is to confront questions about the origins of existence, the nature of time, and the processes that led to life and consciousness. Contrast the clinical certainty of spectral lines with the imaginative speculation they inspire. Why does the universe organize itself in such patterns? Is there an inherent logic, or is it a cosmic accident? Science provides answers in the form of models and predictions, yet it also opens the door to deeper inquiry, reminding us that every discovery is as much an invitation to wonder as it is an acquisition of knowledge. As we continue to study these ancient lights, the tension between certainty and mystery becomes ever more pronounced. Data reveals structure, composition, and motion, yet simultaneously challenges assumptions, suggesting that our theoretical frameworks may be incomplete. The further we look, the more the universe seems to exceed our understanding, prompting both awe and humility. Contrast the elegance of mathematical models with the raw unpredictability of what Webb reveals. It is a cinematic tension, a narrative of exploration where the audience is invited to participate in the unfolding story of cosmic evolution, feeling both the thrill of discovery and the wonder of the unknown. Ultimately, Webb's ability to capture light from the earliest galaxies transforms our understanding of the universe from a static tableau to a dynamic narrative. We witness the birth of stars, the assembly of galaxies, and the interplay of matter and energy in epochs long vanished. In doing so, we gain insight not only into the physical processes that shape the cosmos, but also into the deeper philosophical questions that have driven human curiosity for millennia. Contrast the precision of observation with the immensity of the unknown, and we find ourselves suspended between knowledge and imagination, between what is measured and what is felt, between the evidence of science and the mystery of existence itself. As this section closes, the stage is set for the next phase of exploration. Cosmic surprises that defy expectation. We have glimpsed the light of the earliest galaxies, traced the rhythms of the ancient universe, and felt the duality of data and wonder. Now, the tension heightens. What Webb sees may astonish, perplex, and even redefine our understanding of cosmic evolution. Evidence and speculation converge, preparing the audience for revelations that are as profound as they are unexpected. The universe has begun to speak, and its message is both scientific and deeply philosophical, challenging our understanding of time, space, and reality itself. The universe has a way of humbling those who think they understand it. For decades, cosmologists believed they had sketched the broad strokes of galactic evolution, mapping the rise of stars and the formation of cosmic structures with carefully honed models. Then the James Webb Space Telescope turned its gaze upon the distant cosmos, and those models began to tremble. Webb revealed a universe both familiar and alien, a cosmos that seemed to have defied the rules we thought immutable. Galaxies that should have been chaotic, immature, and faint appeared fully formed, dense, and luminous. Star clusters that were predicted to be small and scattered emerged with surprising complexity. The predictions of theory collided with the raw evidence of observation, and in that collision, science met wonder. Consider the images of unexpectedly mature galaxies, forming within the first few 100 million years after the Big Bang. Previous models suggested that galaxies would coalesce gradually, small clumps of matter slowly merging over time. Webb, however, captured galaxies already organized, with coherent structures glowing brightly with the energy of innumerable young stars. Contrast this with the expectations of scientists. These early galaxies should have been irregular, amorphous, and diffuse. Instead, they exhibited symmetry, mass, and luminosity that challenged assumptions. Here lies the tension between prediction and reality. The universe refuses to conform to human anticipation, offering instead surprises that are as exhilarating as they are confounding. These anomalies extend beyond galaxies. Webb has also detected star formations that defy conventional understanding. Some regions contain stars forming at rates far exceeding what current astrophysical models predicted. Clusters appear densely packed, burning intensely and evolving rapidly. The implications are profound. If stars can form so efficiently in the early universe, our models of matter distribution, energy dynamics, and cosmic evolution must be revisited. Contrast the measured precision of redshifts and spectral analysis with the imaginative reach required to conceptualize mechanisms that might allow such rapid formation. Science provides the numbers. Speculation provides the narrative, and together they invite a reconsideration of what is possible. Yet, even as Webb reveals these anomalies, it does so with scientific rigor. Every observation is corroborated by precise measurements. Luminosity, distance, composition, and redshift are carefully documented. Data is not anecdotal. It is verifiable. But within this rigor, there is a cinematic tension. What the telescope captures is simultaneously evidence and enigma. For instance, some early galaxies appear to have evolved too quickly to fit within the expected timeline dictated by dark matter models. Others hinted structures that seem almost alien, as though the cosmic rules were temporarily rewritten in the universe's youth. Here, certainty and mystery coexist, creating a narrative that is both intellectually compelling and emotionally thrilling. The implications of these cosmic surprises ripple through the scientific community. Some researchers speculate that unknown mechanisms may accelerate galaxy formation. Others entertain more radical ideas, suggesting that the early universe may have been influenced by processes beyond our current understanding. Perhaps exotic physics, unrecognized energy interactions, or even modifications to our models of gravity and matter. Contrast the methodical caution of scientists with the tantalizing allure of these possibilities. It is a delicate balance. Hypotheses must remain grounded in data, yet the imagination is essential to interpret anomalies that challenge existing paradigms. Webb's discoveries exemplify this interplay, highlighting the boundary between known science and the unknowable. One of the most striking revelations is the diversity of galactic forms in the early universe. Some galaxies are compact and intensely luminous, while others are faint, diffuse, and irregular. This variation suggests that the processes governing formation were not uniform. Local environments, interactions, and perhaps unknown cosmic influences played a role. Contrast the precision of Webb's instruments, capturing these variations with exquisite clarity, against the unpredictability of the phenomena themselves. Each galaxy tells a story that is both specific and universal, a record of matter and energy shaped by forces we only partially understand. It is in this contrast that the cinematic beauty of discovery emerges. The universe is precise, yet mysterious. Structured, yet surprising. The telescope's ability to detect faint, previously invisible features opens the door to speculation about exotic cosmic structures. Webb has observed hints of galaxies interacting in ways that challenge gravitational models, filaments of matter connecting distant clusters, and regions of unexpected chemical richness. These features provoke questions. Are there unknown processes accelerating evolution in these regions? Could there be factors influencing early star formation that current models overlook? Contrast the rigor of measured spectra with the imaginative leap required to conceptualize these structures. Webb invites scientists and viewers alike to dwell in uncertainty, to consider possibilities that are scientifically plausible yet profoundly unexpected. These surprises also have implications for our understanding of cosmic history. If galaxies formed more rapidly and efficiently than predicted, the timeline of cosmic evolution may need revision. The early universe might have been more dynamic, more energetic, and more intricate than our models suggest. Contrast the linear, orderly diagrams in textbooks with the complexity Webb reveals, a universe that is less predictable and more astonishing than anticipated. Each discovery reshapes our conception of time, evolution, and the mechanisms that gave rise to the cosmos we inhabit today. Evidence and imagination intersect here, forming a narrative that is both scientifically credible and philosophically provocative. The tension between theory and observation also underscores the humility required in scientific exploration. For decades, models of galaxy formation were based on assumptions grounded in observation and simulation. Webb's data challenges these assumptions, revealing that our understanding of the early universe is still incomplete. Contrast the certainty of historical predictions with the fluidity of new evidence. This is not a failure of science, but its highest expression: the willingness to revise, question, and adapt in the face of truth. The cosmic surprises captured by Webb exemplify this principle, demonstrating that discovery is not a destination, but an ongoing dialogue between observation, theory, and imagination. Even as we analyze these anomalies, the poetic dimension of Webb's discoveries remains inescapable. Each image is a glimpse into a distant past, a visual record of a universe young and vibrant. Galaxies glow with the energy of newborn stars. Star clusters burn fiercely, illuminating the primordial darkness. Contrast the quantitative analysis of luminosity, mass, and chemical composition with the existential resonance of witnessing creation itself. Science provides the lens, but awe provides the emotional framework. Through Webb, we confront the grandeur of the universe, the complexity of its evolution, and the fragility of our own understanding. Speculative interpretations naturally follow these observations. Some scientists propose that unknown physics could accelerate star formation, or that interactions between dark matter and ordinary matter might be more complex than assumed. Others suggest that the early universe may contain structures that challenge our understanding of gravitational dynamics. Contrast these hypotheses with the measured certainty of the data. Every speculation arises from observation, yet pushes beyond conventional explanation. Webb's discoveries do not allow us to remain passive observers. They demand engagement with the unknown, a willingness to explore the boundaries between empirical evidence and imaginative possibility. Another layer of fascination lies in the unexpected chemical richness of early galaxies. Webb's infrared instruments detect elements heavier than hydrogen and helium-carbon, oxygen, even traces of nitrogen, at epochs previously thought too early for such complexity. These findings imply that stars formed and died more rapidly than anticipated, seeding the cosmos with the building blocks of planets, molecules, and eventually, life. Contrast the simplicity of the primordial universe with the richness Webb uncovers. In this discovery, the telescope bridges the gap between astrophysics and the philosophical question of origins. hinting at a universe predisposed toward complexity, abundance, and eventual consciousness. The anomalies captured by Webb also challenge our imagination in more abstract ways. Filaments of matter, intergalactic bridges, and oddly structured star-forming regions hint at a universe that is not only physically dynamic, but perhaps fundamentally unpredictable. Contrast the predictability of models with the wild creativity of nature. Here, science and speculation converge. Data provides evidence, while imagination fills the gaps, creating a cinematic narrative that captivates both the intellect and the spirit. Webb's images become more than measurements. They become a canvas upon which we project questions, wonder, and the thrill of discovery. The implications of these cosmic surprises extend beyond astronomy. If the universe evolved faster, more dynamically, and more intricately than predicted, the very assumptions about our cosmic context must be reevaluated. The boundaries between the known and the unknown blur. What Webb observes may hint at processes we have yet to comprehend, forces and interactions that shape the universe in ways still hidden. Contrast the confidence of established theory with the humility imposed by new evidence. In this tension, we find the essence of scientific exploration, the courage to confront the unfamiliar, the discipline to measure it, and the imagination to integrate it into a broader understanding of reality. Finally, these discoveries prime the audience for deeper reflection. We have seen galaxies that defy expectation, stars forming with astonishing rapidity, and structures that hint at unknown cosmic processes. Evidence and speculation coexist, teasing the limits of comprehension. Webb's revelations invite us to question the boundaries between what is known, what is assumed, and what remains unimaginable. They remind us that the universe is not static, not easily categorized, and not fully predictable. The telescope has not only expanded our vision, but has also expanded our capacity to wonder, compelling us to confront the extraordinary and the unknown in ways previously unimaginable. As this section closes, the stage is set for contemplation of the broader implications. Webb's cosmic surprises are more than anomalies. They are provocations, challenging our understanding of galactic evolution, the mechanics of the early universe, and the very nature of existence. Evidence and mystery, theory and observation, fact and speculation converge. The audience is left at the threshold of an even deeper journey, exploring how these revelations about the universe's infancy resonate with human understanding of time, space, and reality itself. The cosmos has surprised us, and now we must grapple with what those surprises truly mean. As the James Webb Space Telescope peers into the ancient universe, capturing light from the first galaxies and stars, it is tempting to feel detached, as though these cosmic events exist in a realm far removed from our own. Yet, the story of the cosmos is deeply entwined with the story of Earth. The very atoms that compose our bodies, the elements that form the soil beneath our feet, the metals in our technology, and the oxygen we breathe were forged in the hearts of stars long before our planet existed. The telescope's revelations about early galaxies and rapid star formation are not distant curiosities. They are the foundation upon which life, civilization, and human consciousness eventually emerged. Here, the universe is not abstract. It is intimately connected to every molecule, every heartbeat, every thought on Earth. Consider carbon, oxygen, nitrogen, and iron, the essential elements of biology and civilization. These elements were not present in the universe's initial simplicity of hydrogen and helium. They were synthesized in the nuclear furnaces of stars, expelled in supernova, and scattered across space, eventually coalescing into planets and life-bearing systems. Webb allows us to trace these elements back to their stellar origins. By observing galaxies forming just hundreds of millions of years after the Big Bang, the telescope shows us where the raw materials for planets like Earth first emerged. Contrast this with humanity's brief tenure on this planet, mere fractions of the cosmic timeline. In this light, our existence is simultaneously improbable, precious, and profoundly connected to the vast processes of the universe. Earth, in context, is both extraordinary and ordinary. Extraordinary because its composition, orbital position, and environmental conditions allowed life to flourish. Ordinary because it is part of a continuum of matter and energy stretching back to the first stars observed by Webb. Every atom in our bodies has a history that predates the sun, predates our solar system, predates even our galaxy. Contrast the fleeting nature of human life with the billions of years over which stars have formed, evolved, and died. Yet within this vast temporal framework, our species has developed consciousness capable of reflecting on its own origins and, through instruments like Webb, reaching toward the edges of the universe itself. The telescope's observations reveal galaxies that matured rapidly, producing heavy elements far earlier than expected. These heavy elements, carbon, oxygen, silicon, and more, would later become the building blocks of rocky planets, asteroids, and the complex chemistry essential for life. Contrast the ancient universe's violent, energetic star formation with the calm stability we experience on Earth today. What appears as cosmic chaos from a human perspective was, in fact, the necessary crucible for life. It is a dramatic illustration of the interdependence of destruction and creation, of explosive astrophysical events seeding the potential for life billions of years later. Our understanding of Earth's origins is inseparable from these cosmic processes. The planet formed from a disk of gas and dust orbiting the young sun, a mix of primordial hydrogen, helium, and elements produced by preceding generations of stars. Webb's glimpses of early galaxies offer insights into the processes that generated these elements, providing a deeper appreciation of Earth as a child of the cosmos. Contrast this scientific narrative with the human experience of daily life. Our routines and concerns occupy mere decades, while the materials of our bodies have existed across eons. In this juxtaposition, existential wonder arises naturally. Our lives, so fleeting, are nonetheless composed of the echoes of ancient stellar cataclysms. Beyond the chemical origins of life, Webb's observations also illuminate the dynamics of cosmic evolution that shape planetary systems. Star formation, supernova explosions, and the dispersal of matter dictate the abundance of elements and the environments in which planets emerge. This is not abstract science. It is the framework that allowed Earth to develop as a habitable world. Contrast the precision of observational astrophysics with the philosophical questions it inspires. Are planets like Earth rare or inevitable? Does the universe favor the emergence of life, or is it a fleeting accident? Webb's revelations push us to confront these questions with empirical grounding, while inviting imaginative speculation. The telescope also underscores the scale of cosmic time. When we observe galaxies forming a billion years after the Big Bang, we witness processes that predate the formation of the solar system by billions of years. Contrast this with the roughly 4.5 billion year age of Earth and the mere hundreds of thousands of years that humanity has existed. The juxtaposition highlights the brevity of human history against the immensity of cosmic evolution. And yet, our species has developed the capacity to observe and understand these ancient processes, bridging the gulf between fleeting life and eternal cosmic cycles. Webb's ability to detect chemical signatures in distant galaxies also provides clues about the potential for life elsewhere. Elements essential for life on Earth, carbon, nitrogen, oxygen, are abundant throughout the cosmos, produced in the very galaxies Webb observes. This raises profound questions. If these elements exist elsewhere, in galaxies that form nearly simultaneously with our own, might life have arisen elsewhere in the universe? Contrast the empirical certainty of chemical abundance with the speculative wonder of extraterrestrial life. Webb offers data that the imagination fills in the possibilities, inviting philosophical reflection on the universality of life, the conditions that favor its emergence, and our place in a potentially teeming cosmos. The cosmic perspective that Webb affords reshapes how we view human civilization. Societies, cities, technologies, and cultures emerge over mere millennia blink of an eye events on the scale of cosmic evolution. Yet every aspect of civilization depends upon the long chain of events set in motion by the earliest stars. Contrast the immediacy of human endeavor with the patient, inexorable unfolding of the universe. In recognizing that our existence is linked to processes spanning billions of years, viewers are invited to reflect on the fragility, resilience, and significance of life on Earth. The telescope bridges the gap between the infinitesimal and the infinite, illustrating that humanity's story is nested within a much larger cosmic narrative. The philosophical resonance deepens when considering the telescope's role in connecting us to our origins. Webb does not merely provide images. It reconstructs a history that explains the conditions for life, the creation of matter, and the assembly of planetary systems. It is a mirror reflecting both the universe's vastness and our intimate connection to it. Contrast this with the human perception of separateness, the illusion that Earth and its inhabitants exist independently of cosmic forces. Webb reminds us that life, civilization, and consciousness are outcomes of cosmic evolution, that our existence is woven into a grander pattern, extending from the first galaxies to the present day. In contemplating Earth's place in this framework, one cannot ignore the fragility and rarity of habitable conditions. While elements may be widespread, the precise circumstances that allow a planet like Earth to sustain life are delicate. Webb's observations highlight the interplay of timing, location, and stellar processes that make life possible. Contrast the chaotic violence of early galaxy supernova, gamma-ray bursts, intense radiation with the stable environment Earth eventually achieved. Humanity occupies a brief, transient window of stability, a testament to the improbability and wonder of existence. This perspective inspires both humility and awe, reinforcing the idea that we are participants in a cosmos that is at once orderly and unpredictable. The telescope's revelations also invite reflection on the continuity between Earth and the universe. The iron in our blood, the calcium in our bones, the oxygen in our lungs, all were forged in the interiors of stars observed by Webb in distant galaxies. Contrast this empirical truth with the human experience of daily life. The profound history of matter is invisible to the eye, yet it is embedded in our very being. This connection transforms a scientific observation into a philosophical meditation. Humanity is not merely on Earth. It is of Earth and, by extension, of the cosmos itself. Webb provides the data, but the awareness of this connection evokes a sense of cosmic belonging and existential reflection. Consider also the implications for understanding life beyond our planet. If the elements essential for life are distributed across galaxies forming in the universe's infancy, might there be other worlds with conditions similar to Earth? Webb offers glimpses of the chemical diversity of distant systems, hinting that the ingredients for life are not unique to our solar system. Contrast the certainty of what we know about Earth with the possibilities suggested by these observations. This tension between empirical evidence and speculative wonder is at the heart of cosmic exploration, inviting audiences to consider the universality of life and the profound questions of existence that arise when we connect planetary history to cosmic evolution. The telescope's discoveries also reinforce the fleeting nature of human perspective. While Earth has existed for billions of years, our species has only just begun to observe, analyze, and comprehend the universe's history. Contrast this brief window of consciousness with the vast cosmic timeline illuminated by Webb. Galaxies forming, stars dying, elements dispersing, planets coalescing, and life emerging. Humanity's ability to perceive and interpret these events is extraordinary. Yet it underscores our temporal smallness, our participation in an ancient, ongoing process that spans the entirety of time and space. Webb also illustrates the dynamic interplay between observation and imagination. By providing data about early galaxies, element formation, and cosmic evolution, it allows scientists to reconstruct the history that led to Earth's formation. Yet, in interpreting these data, imagination is required to connect the dots, to visualize the processes that cannot be directly observed, and to consider the philosophical implications. Contrast the precision of spectra and light curves with the expansive speculation they inspire. Science provides the framework. Imagination provides the depth. Together, they transform distant photons into a narrative of origins, linking human curiosity with the cosmos itself. Finally, as we contemplate Earth in cosmic context, the telescope's revelations inspire a profound synthesis. The story of our planet, our civilization, and our consciousness is inseparable from the universe's ancient history. Every atom, every molecule, every breath carries the legacy of stars observed by Webb. Contrast humanity's fleeting lifespan with the billions of years over which these processes unfolded. In doing so, we confront both the fragility and significance of existence, the improbability of life, and the extraordinary circumstances that have allowed us to reflect on our own origins. The telescope bridges distance, time, and scale, connecting the earliest galaxies to the very essence of life on Earth. In this section, viewers are invited to marvel at the continuity between the cosmos and Earth, to appreciate that our origins are written in the stars, and to recognize that the telescope's revelations extend beyond observation. They evoke philosophical reflection. The ancient universe captured by Webb is not distant or abstract. It is intimately linked to every aspect of our existence. This awareness prepares the audience for deeper contemplation of humanity's place in the cosmos, the potential for life beyond our planet, and the philosophical implications of a universe whose history is inseparable from our own. As Webb continues to gaze across the cosmos, its observations are not confined to distant galaxies and ancient stars. The telescope's unparalleled sensitivity to infrared light opens a doorway into the search for life beyond Earth, illuminating planets, atmospheres, and molecules that may harbor the conditions necessary for existence elsewhere. The search for life is no longer a philosophical musing. It is becoming an empirical pursuit, grounded in observation, spectral analysis, and the careful interpretation of light. Yet even within this rigor, the endeavor invites imagination, speculation, and profound reflection on the nature of life, consciousness, and our place in the universe. Consider the growing catalog of exoplanets identified in the past few decades. Thousands have been discovered orbiting distant stars, some located within the so-called habitable zone, where conditions might allow liquid water to exist. Webb's infrared instruments provide an unprecedented ability to examine these worlds more closely, analyzing their atmospheric composition, temperature gradients, and chemical signatures. Contrast this technical achievement with the sheer vastness of possibility. Billions of stars in our galaxy alone, each potentially hosting multiple planets and billions of galaxies in the observable universe. The probability that conditions suitable for life exist elsewhere is staggering, yet uncertainty remains. Life, as we know it, is just one manifestation of what might be possible. The telescope's spectroscopic capabilities allow scientists to detect organic molecules and potential biosignatures on distant exoplanets. Methane, water vapor, carbon dioxide, and even more complex compounds can reveal the presence of chemical processes reminiscent of those that sustain life on Earth. Contrast the precision, of these measurements with the philosophical leap required to interpret them. Even if molecules associated with life are detected, do they confirm biological activity or merely chemical processes? Webb operates at the intersection of certainty and conjecture, delivering data that is exact while simultaneously pointing to questions that cannot yet be definitively answered. Speculation becomes unavoidable when considering the forms life might take beyond Earth. Our understanding of biology is rooted in terrestrial experience, DNA, RNA, proteins, and cellular structures. Yet the universe is vast and diverse, and life may exist in forms radically different from our own. Contrast the familiarity of Earth's ecosystems with the strangeness of potential alien environments. Gas giants with high-pressure atmospheres, icy moons beneath frozen surfaces, planets bathed in radiation from multiple suns. Webb allows us to glimpse these worlds, but it cannot fully reveal the possibilities they hold. Here, scientific observation meets philosophical imagination, challenging us to expand the definition of life itself. The search for extraterrestrial life also raises questions about our own existence and uniqueness. Humanity has long pondered whether life elsewhere would mirror our own in complexity, intelligence, or consciousness. Contrast the empirical rigor of Webb's observations with the existential speculation they inspire. If life is discovered, how will it reshape our understanding of biology, evolution, and the universality of consciousness? Even the mere possibility of life beyond Earth forces a reconsideration of human significance in the grand cosmic narrative. We are no longer simply observers of the universe. We are participants in an unfolding story that may extend far beyond our pale blue dot. Webb's discoveries also challenge the anthropocentric assumptions often embedded in the search for life. While humans may naturally conceive of life in forms similar to our own, the universe does not conform to our expectations. Contrast the predictability of laboratory biology with the unpredictability of alien ecosystems. What we consider essential water, oxygen, stable climates may not be necessary for other forms of life. The telescope enables us to identify chemical and physical conditions that are conducive to life as we know it. But the possibility remains that life could arise under circumstances entirely alien to human experience. In this tension, curiosity, rigor, and imagination converge. One of the most compelling aspects of Webb's search is its ability to detect planets around stars that formed early in the universe's history. By studying these ancient systems, scientists can explore whether the building blocks of life were present billions of years before our sun existed. Contrast this ancient cosmic perspective with the immediacy of human life. Life on Earth has existed for only a fraction of cosmic time, yet we now have the tools to investigate the potential for life in epochs far older than our own. These observations extend our understanding of habitability, suggesting that the conditions necessary for life may have been present throughout much of cosmic history. The telescope also informs the study of planetary atmospheres in remarkable detail. By analyzing the spectra of light passing through these atmospheres, scientists can detect trace gases, temperature variations, and cloud structures. This information is critical for assessing the potential for habitability, identifying biosignatures, and distinguishing between lifeless and potentially life-bearing worlds. Contrast the meticulous methods of spectroscopy with the profound implications of the findings. What once seemed like science fiction is now measurable, observable, and within the reach of empirical investigation. Webb transforms the philosophical question, "Are we alone?" into a tangible scientific endeavor. Yet, the search for life is not merely a scientific quest. It carries deep societal and philosophical consequences. Consider the scenario in which evidence of extraterrestrial life is confirmed. Humanity would be confronted with the profound realization that life is not unique to our planet. That consciousness and biology may have emerged elsewhere independent of Earth's particular conditions. Contrast the certainty of such a discovery with the uncertainty of its implications. How would it affect religion, culture, ethics, and our perception of ourselves? How would societies adapt to the knowledge that we are part of a broader, potentially inhabited universe? The telescope, by extending our vision, also extends the realm of existential contemplation. Even in the absence of definitive confirmation, Webb's observations foster philosophical reflection. The discovery of planets with Earth-like atmospheres, organic molecules, or conditions conducive to life invites us to consider the universality of existence. Contrast this with human perception, limited to the immediate environment of our solar system. The telescope expands our awareness, situating humanity within a cosmic context that is simultaneously humbling and exhilarating. Every exoplanet studied, every spectrum analyzed, is a step toward understanding whether the story of life on Earth is a unique anomaly or part of a greater cosmic pattern. The telescope's capabilities also encourage interdisciplinary dialogue, bridging astronomy, biology, chemistry, and philosophy. The search for life requires understanding chemical pathways, planetary formation, stellar evolution, and the conditions necessary for self-sustaining systems. Contrast the narrow specialization of individual scientific disciplines with the integrative perspective demanded by the search for life. Webb exemplifies this synthesis, demonstrating that exploring extraterrestrial life is not only a scientific challenge, but also a philosophical and intellectual journey. Speculation, however, remains a necessary companion to observation. Even as Webb detects atmospheres, traces of organic compounds, and chemical anomalies, the question of actual life remains unresolved. Contrast the empirical certainty of spectral data with the imaginative possibilities it suggests. Might we encounter life that communicates in ways incomprehensible to humans? Could consciousness exist in forms entirely unlike our own? The telescope allows us to ask these questions with seriousness, grounding speculation in observation and turning the act of wondering into a scientific dialogue. The search for life also forces reflection on the rarity and resilience of life on Earth. While elements essential for life are abundant in the universe, the precise combination of conditions that allowed life to flourish here is extraordinarily delicate. Contrast the vast abundance of matter with the specific arrangements required for biology: a habitable zone, a stable climate, liquid water, chemical diversity, and time for evolution. Webb's observations reveal planets in these delicate positions, hinting that life may exist elsewhere, yet reinforcing the sense of improbability that makes our own existence remarkable. Webb's discoveries thus provoke a dual response: scientific curiosity and existential awe. As we detect potential biosignatures, identify planets in habitable zones, and study atmospheres rich in organic molecules, we are compelled to consider what life represents. Contrast the measurable with the meaningful. Life is not only a chemical process, but also a philosophical concept, raising questions about consciousness, intelligence, and the potential for moral or aesthetic experience beyond Earth. The telescope bridges the empirical and the existential, making the search for life an endeavor that is as much about understanding ourselves as it is about discovering other worlds. The philosophical implications are profound. If life is found elsewhere, it may reveal that consciousness, sentience, or self-organization are natural outcomes of the universe's evolution, rather than rare accidents. Contrast this with the traditional human-centric view that life and intelligence are unique to Earth. Such a discovery would transform our understanding of cosmology, evolution, and the role of consciousness in the universe. Webb's observations thus extend beyond planetary science into questions that have occupied philosophers for centuries. What does it mean to exist, to observe, to be aware? Even without definitive confirmation of extraterrestrial life, the telescope reshapes our perspective. Each planet examined, each atmosphere analyzed, each spectral line interpreted adds to a growing picture of a universe that may be teeming with potential. Contrast the tentative nature of current findings with the grandeur of the questions they inspire. We are observers of a universe that is alive with possibility, a cosmos where the emergence of life may be a common thread woven into the fabric of time and space. Webb invites us to contemplate these possibilities with both scientific rigor and imaginative openness. The societal impact of discovering life would be equally transformative. Consider how human civilization might reinterpret history, religion, philosophy, and ethics in light of a confirmed extraterrestrial presence. Contrast the stability of human belief systems with the disruption such knowledge could bring. The telescope thus acts as a catalyst for reflection, compelling society to examine its assumptions, values, and place in the cosmos. Webb provides the data. Humanity must interpret the meaning. In this dialogue between evidence and significance, science becomes a gateway to existential contemplation. The search for life also illuminates the limits of human perception. Until recently, our understanding of distant planets and their atmospheres was largely theoretical, constrained by indirect measurements. Webb, with its infrared vision and exquisite sensitivity, transforms conjecture into measurable data. Contrast the previous reliance on models with the ability to observe, detect, and analyze directly. This shift embodies the cinematic drama of discovery. The universe, once hidden, now reveals hints of its potential to host life, challenging both our scientific and philosophical frameworks. In addition, Webb's discoveries emphasize the diversity of potential habitats. Life on Earth exists under a narrow range of conditions, yet the universe presents a staggering variety of environments. Moons with subsurface oceans, planets with exotic atmospheres, worlds bathed in radiation from multiple suns. Contrast the familiarity of Earth with the strangeness of these worlds. Each new observation expands the range of possibility, reminding us that life may be more adaptable, more resilient, and more surprising than our terrestrial experience alone would suggest. Ultimately, the search for life is inseparable from questions about consciousness and the significance of existence. Webb allows us to detect planets, analyze atmospheres, and identify organic molecules, but the deeper question persists. What does it mean for life to exist elsewhere, and what does that tell us about ourselves? Contrast the objective data with subjective reflection. As we seek life beyond Earth, we also confront our own consciousness, mortality, and the profound mystery of being. The telescope extends human vision into the cosmos, and in doing so, extends human thought into realms of existential wonder. As we prepare to move from the search for life to broader cosmic implications, the narrative tension is palpable. Webb has shown us planets that might host life, atmospheres rich in potential, and chemical signatures that echo the processes of our own world. Contrast these possibilities with the uncertainties that remain. Life may exist in forms we cannot yet imagine, and consciousness may arise in ways we cannot yet comprehend. The telescope's observations are both revelation and question, evidence and invitation, grounding speculation in data while opening the mind to profound wonder. The search for life, therefore, is both scientific and philosophical. Webb provides the eyes, enabling observation, measurement, and analysis. Human curiosity provides the mind, interpreting, speculating, and reflecting on the meaning of these discoveries. Contrast the empirical with the imaginative, certainty with possibility, the known with the unknowable. In doing so, the telescope becomes more than an instrument. It is a bridge between the universe's mysteries and humanity's desire to understand them, a conduit through which we confront the potential ubiquity of life and the extraordinary nature of our own consciousness. In this section, Viewers are invited to journey beyond Earth, to consider worlds we have yet to touch, and to contemplate the forms life might take across the cosmos. Webb's observations ground this speculation in reality, providing data that is precise, reliable, and transformative. Contrast the tangible evidence with the expansive unknown. We know there are planets, atmospheres, and chemical processes. We do not yet know whether life exists elsewhere. Yet in this tension lies the beauty of discovery, the thrill of exploration, and the profound philosophical question that will drive human curiosity for generations. In a universe capable of producing life, what does it mean to be alive? And what does it mean to be conscious? As Webb gazes across billions of light years, capturing galaxies in their infancy, it is easy to become enthralled by scale, the vast distances, the ancient light, the cosmic evolution of matter itself. But lurking beneath this grandeur is another layer of reality, one that is invisible to telescopes, yet fundamental to everything we observe: the quantum world. Here, the rules are radically different. Particles exist in superpositions. Separated objects can influence one another instantaneously across vast distances, and the act of observation itself can alter the outcome of events. Contrast this microscopic strangeness with the apparent order of the cosmos. Webb reveals a galaxy spinning, stars igniting, elements forming. The quantum domain, though unseen, may underlie and even shape the grand cosmic structures we study. Quantum entanglement is one of the most perplexing phenomena, a bridge between certainty and mystery. Two particles, once linked, can remain connected no matter the distance separating them. Change one, and the other responds instantly, defying classical ideas of causality and locality. Contrast this instantaneous connection with the slow march of cosmic light we observe from ancient galaxies. In one domain, vast expanses stretch for billions of years. In the other, quantum effects occur in the blink of an eye, as if the universe itself contains threads linking the infinitesimal with the infinite. This tension between the scales, the enormous and the minuscule, invites both scientific inquiry and philosophical reflection. The observer effect, another cornerstone of quantum mechanics, challenges the notion of objective reality. In certain experiments, the very act of measurement alters what is being measured. Applied to the cosmos, it raises questions that are both exhilarating and unsettling. Do we shape reality simply by observing it? Contrast this with the apparent independence of galaxies and stars. They appear indifferent to human perception. Yet, in a deeper sense, the quantum framework suggests that observation and reality are intertwined in ways we are only beginning to grasp. Webb, by extending our observational reach, participates in this subtle interplay between consciousness and the cosmos. Multiverse theories push these ideas further, suggesting that the universe we inhabit may be one of countless others, each with its own physical laws, histories, and possibilities. Contrast the rigor of astrophysical measurement with the speculative imagination required to entertain such ideas. Webb reveals galaxies, stars, and elements formed under known physical laws. Yet quantum principles hint at vast domains beyond direct observation. In this cinematic vision, the universe is not merely a single comprehensible expanse. It may be a fractal of infinite possibilities, each reality branching, folding, and coexisting with our own. The link between the quantum and the cosmic also emerges in the study of cosmic background radiation, gravitational waves, and the behavior of matter under extreme conditions. These phenomena reflect quantum fluctuations magnified to universal scales. Contrast the tangible light Webb captures with the invisible ripples of spacetime shaped by quantum uncertainty. In this interplay, the cosmos is revealed as both comprehensible and profoundly mysterious. Galaxies, stars, and planets obey classical physics. Yet beneath them, The quantum substrate suggests a reality far stranger than appearances indicate. Quantum mechanics also informs our understanding of the origins of the universe itself. Theories of inflation and the quantum fluctuations of space-time in the earliest moments after the Big Bang suggest that the seeds of galaxies and ultimately planets and life arose from phenomena rooted in uncertainty and probabilistic events. Contrast this with the precise, seemingly deterministic orbits of planets and the chemical predictability of life's building blocks. The cosmos, viewed through this lens, is both ordered and emergent, governed by laws yet enriched by randomness. Webb's glimpses of early galaxies may thus be seen as windows into the manifestation of quantum processes on a cosmic scale. Entanglement, the observer effect, and probabilistic emergence do more than challenge physicists. They unsettle our philosophical assumptions about reality. If observation affects reality, if particles can be linked across vast distances, and if universes may exist beyond our perception, then the universe is stranger than intuition allows. Contrast this uncertainty with the confidence humans often feel in their understanding of the cosmos. Webb provides data, clarity, and empirical evidence. Yet the quantum layer reminds us that reality may contain aspects that elude observation, measurement, and comprehension. This tension between knowledge and mystery expands the audience's sense of awe, inviting contemplation that is both scientific and existential. The cinematic nature of quantum mysteries cannot be overstated. Imagine a galaxy illuminated by Webb's infrared vision, light traveling billions of years to reach the telescope. Within the very atoms of that light may reside quantum histories, probabilities, and entanglements that defy classical understanding. Contrast the visible sweep of cosmic structure with the hidden, invisible choreography of subatomic events. In this interplay, the universe becomes a multi-layered stage, the macroscopic drama of stars and galaxies, underpinned by a microscopic narrative that is dynamic, unpredictable, and astonishingly intimate. Consider, too, the implications of quantum mechanics for the emergence of consciousness. Some interpretations suggest that quantum processes may play a role in the mind's ability to perceive, process, and reflect upon reality. Contrast the enormity of galaxies with the complexity of awareness. Within a human brain, quantum-scale interactions may contribute to thought, choice, and perception. While billions of light-years away, galaxies evolve under the same fundamental principles. This mirroring of scales from the interior of consciousness to the cosmic expanse offers a cinematic framework for pondering existence. Our minds, though fleeting, may resonate with the universe itself at a fundamental level. The idea of multiple realities, or the multiverse, also challenges conventional notions of causality, identity, and destiny. If countless universes exist, each unfolding differently, then the universe we observe is one of infinite possibilities. Contrast this speculative vision with the empirical certainty of Webb's data. We see galaxies, stars, and elements behaving predictably under known laws. Yet quantum principles suggest that behind these apparent certainties lies a landscape of alternatives, branching pathways, and realities that may never be directly observed. In contemplating this, audiences are invited to consider the limits of perception and the extraordinary richness of what may exist beyond sight. Quantum entanglement further complicates our understanding of connection. If particles can influence each other across space instantaneously, then locality, a foundational concept in classical physics, is incomplete. Contrast this with the apparent isolation of cosmic structures observed by Webb. Galaxies separated by millions of light-years seem independent. Yet the quantum substrate hints at a universe where separation is illusory, where connection is woven into the fabric of existence itself. This tension between independence and entanglement deepens both scientific curiosity and philosophical reflection. The observer effect, too, forces us to reconsider the role of consciousness in shaping reality. In the act of observation, the universe responds, collapsing probabilities into tangible outcomes. Contrast the meticulous observations of Webb, grounded in instrumentation and measurement, with the subtle suggestion that consciousness might be fundamental to the unfolding of reality. While scientists focus on photons, spectra, and infrared data, the philosophical implication lingers. Does perception itself play a role in the manifestation of the cosmos? The boundary between the objective and the subjective begins to blur. Multiverse hypotheses amplify this interplay between the known and the unknowable. Each universe may possess different physical constants, laws, and histories, leading to realities that are radically divergent from our own. Contrast this speculative vision with the observable universe Webb studies. We see matter, energy, and cosmic evolution behaving consistently across billions of years. Yet these glimpses may represent just one thread in a tapestry of infinite possibilities. The cinematic implication is staggering. The universe we know may be but a single act in an eternal, unobservable performance of cosmic diversity. Quantum mysteries also shape our interpretation of time. In classical physics, time flows linearly, a continuous progression from past to future. Quantum theory, however, suggests that at fundamental scales, time may be nonlinear, probabilistic, and entangled with space itself. Contrast this with the apparent regularity of cosmic events. Stars form, galaxies evolve, planets orbit predictably. Beneath this order, the substrate of time may be far more fluid and strange than our perception allows, offering a cinematic lens through which to view the universe as a living, dynamic, and sometimes paradoxical entity. The tension between quantum mechanics and cosmic observation heightens the sense of wonder. Webb shows galaxies forming, evolving, and sometimes behaving unexpectedly. Contrast this observable clarity with the underlying quantum uncertainty. Particles, fields, and waves may operate according to principles that defy macroscopic intuition. In this duality, precise observation against a backdrop of probabilistic uncertainty, the universe appears both knowable and infinitely mysterious. Audiences are invited to navigate this tension, oscillating between evidence and speculation, comprehension and awe. Entanglement, multiverses, and observer-dependent realities suggest that the universe is a far stranger place than we perceive. Contrast the scale of human observation with the potential complexity of reality. Our telescopes extend vision across billions of light years. Yet quantum principles remind us that the deepest truths may lie in the unseen, the infinitesimal, and the fundamentally unknowable. Webb's observations, in this sense, become more than scientific data. They are an invitation to expand consciousness, to contemplate the interplay between observation, reality, and possibility. Finally, the quantum perspective reframes existential questions about human existence. If the universe is a multiverse of possibilities, if observation shapes reality, if entanglement binds the cosmos in subtle ways, then our place in the universe is simultaneously both central and marginal. Contrast the certainty of human perception with the profundity of quantum possibility. We are observers, participants, and perhaps co-creators in a reality far more complex than our senses suggest. Webb, by revealing the cosmos at its grandest scale, acts as a gateway to these intimate, unsettling, and magnificent questions in this section. Viewers are invited to journey from the vastness of galaxies to the strangeness of quantum mechanics, exploring a universe where certainty is relative, observation matters, and reality may be far stranger than imagination allows. Webb provides the cosmic stage. Quantum principles provide the hidden, intricate choreography. Together, they expand the audience's sense of awe, blending rigorous science with philosophical speculation. and preparing minds to confront existential questions about consciousness, reality, and our place in a cosmos that is infinitely layered and endlessly mysterious. From the vast stretches of galaxies captured by Webb to the quantum mysteries underlying reality, our gaze inevitably returns to Earth, to the civilizations that first looked skyward with wonder and curiosity. Long before telescopes, satellites, or infrared imaging, humans charted the heavens with naked eyes, connecting celestial patterns to the rhythms of life, death, and destiny. Contrast the precision of Webb's instruments with the human imagination tracing lines between stars, creating constellations, myths, and cosmologies. The night sky has always been both a map and a mirror, a reflection of the universe beyond, and of humanity's desire to comprehend it. Consider the ancient Sumerians, whose ziggurats reached skyward as though to touch the heavens themselves. They observed the movements of planets and stars, recording them meticulously on clay tablets. Contrast these rudimentary observations with the immense capabilities of modern telescopes. Whereas the Sumerians inferred celestial patterns through repetitive cycles, Webb measures photons that travel billions of years across space. Yet the underlying impulse is the same, a yearning to understand the cosmos, to find meaning in the light above. Scientific precision may differ, but the curiosity that drives it is timeless. The Egyptians also aligned their pyramids and temples with celestial phenomena. Orion's belt, the sun, and the solstices were more than guides for agriculture or ritual. They were symbols of cosmic order. Contrast this symbolic interpretation with the empirical data Webb now collects. While ancient civilizations wove myth, ritual, and architecture into their understanding of the heavens, modern science seeks patterns through measurement, spectra, and infrared imaging. Yet both endeavors are expressions of the same profound human impulse, to locate ourselves within the vast, silent theater of the cosmos. Ancient myths further demonstrate humanity's desire to map cosmic truths onto human experience. Stories of gods, heroes, and celestial beings encoded observations, moral reflections, and cultural memory into narratives that survived millennia. Contrast the scientific timelines of star formation, galaxy evolution, and planetary birth with these imaginative stories. One is precise, measurable, and chronological. The other is symbolic, interpretive, and layered with metaphor. Yet both reflect attempts to grapple with the infinite, to reconcile human fragility with the permanence of the stars. The Greeks, too, sought cosmic understanding, blending observation with philosophy. Figures like Pythagoras and Plato saw mathematical harmony in celestial movement, speculating that the universe operated according to principles that transcended human perception. Contrast their reasoning with Webb's direct observation of ancient galaxies. Where the philosophers relied on abstract thought, Webb provides empirical data. Yet the elegance of mathematical insight persists. The patterns that guide ancient philosophy resonate in the regularity, symmetry, and structure revealed by modern astronomy. Observation and imagination, measurement and speculation converge across the millennia. In Mesoamerica, civilizations such as the Maya created complex calendars and observatories to track the movements of Venus, the Moon, and the Sun. Their records reflect an astonishingly sophisticated understanding of time, celestial cycles, and the interconnection between sky and society. Contrast this intimate, human-scale engagement with cosmic phenomena with Webb's panoramic vision of galaxies, billions of light-years away. One approach quantifies cycles visible from Earth. The other measures ancient light from the universe's infancy. Yet both represent humanity's enduring quest to interpret the cosmos, to decode the celestial signals, and to find meaning within them. The connection between astronomy and human culture extends beyond mere observation. Star lore informed agriculture, navigation, ritual, and philosophy, providing a framework through which civilizations understood change, permanence, and mortality. Contrast these cultural imperatives with the objective motivations of modern astrophysics. Webb seeks to understand formation histories, chemical compositions, and cosmic evolution, while ancient humans sought survival, continuity, and meaning. Yet in both cases, the night sky functions as a guide, a silent teacher revealing both physical patterns and existential truths. Architecture and alignment in ancient civilizations reveal a tangible dialogue with the cosmos. Stonehenge, the Great Pyramids, and Chichen Itza demonstrate careful attention to solstices, equinoxes, and planetary alignments. Contrast this deliberate positioning with the random distribution of galaxies across billions of light years, as revealed by Webb. On one scale, cosmic objects drift according to gravitational dynamics. On another, humans imposed intention, design, and purpose onto the sky. Yet both phenomena underscore the universality of observation. Whether through instinctive alignment or precise measurement, both reflect a drive to comprehend and engage with the cosmos. Myth and philosophy, architecture and observation, all converge in a timeless narrative. Humans have always sought to connect with the stars. Contrast the temporal brevity of human history with the age of the cosmos. Our civilizations exist for mere millennia. The galaxies Webb observes formed billions of years ago. And yet, despite our fleeting presence, the impulse to look up, to map, to measure, and to imagine has persisted. This is a cosmic memory encoded in human culture, an echo of the universe imprinted on our minds, myths, and monuments. Consider the alignment of ancient civilization's spiritual and technological pursuits with contemporary science. In many ways, telescopes like Webb extend this same quest, translating metaphor and myth into photons and spectra. Contrast the symbolic language of the ancients with the language of infrared detection, yet recognize the shared curiosity. Both seek to penetrate the veil of darkness and comprehend the hidden structure of the cosmos. The bridge between past and present is not merely historical. It is conceptual, philosophical, and profoundly human. The fascination with the stars also shaped ethical and philosophical inquiry. In observing celestial regularity and cosmic order, ancient philosophers contemplated the nature of fate, free will, and the structure of reality. Contrast this with contemporary philosophical discussions of cosmic evolution, multiverses, and quantum mechanics. While the methods differ, storytelling versus spectroscopy, ritual versus mathematics, the questions are fundamentally aligned. What is our place in the universe? How do order, chance, and time interact? What does it mean to exist in a cosmos so vast, ancient, and mysterious? In addition, ancient civilizations often encoded astronomical knowledge in ways designed to endure. Monumental architecture, oral tradition, and ritual practice preserved celestial understanding across generations. Contrast this with the fleeting immediacy of digital observation. Webb records photons for immediate analysis, yet the knowledge must be interpreted, archived, and communicated. Ancient humans faced challenges of preservation through stone, memory, and culture. Modern scientists face challenges of precision, interpretation, and scale. Both demonstrate a profound recognition. The universe is complex, but observation and recording allow understanding to accumulate across time. The mythic imagination of ancient cultures often anticipated scientific discovery in striking ways. Celestial deities, cosmic cycles, and creation stories encoded observations of planetary motion, stellar evolution, and astronomical cycles. Contrast the empirical rigor of modern science with this allegorical encoding. Myths are not literal data, yet they capture patterns, correlations, and insights about the universe. Webb, in turning light into measurable information, continues this process, observing patterns, interpreting structure, and connecting cosmic phenomena to human understanding, albeit through the tools of physics rather than narrative. in reflecting on ancient civilizations, one cannot ignore the aesthetic and emotional resonance of the stars. Humans experienced awe, wonder, fear, and reverence in observing the night sky. Contrast this with the analytical precision of Webb's measurements, photons, spectra, and infrared imaging. Yet the emotional response remains constant. We are moved by the cosmos, whether through myth, philosophy, or direct observation. The telescope may quantify, but it does not diminish wonder, it amplifies it, connecting contemporary awe to the timeless experience of our ancestors. This historical continuity emphasizes a timeless quest for knowledge. Across civilizations, humans have sought to understand the cosmos, asking questions that bridge science, philosophy, and spirituality. Contrast the finite perspective of a single human lifetime with the persistent, multi-generational pursuit of cosmic insight. The ancients looked upward and dreamed. Today, Webb looks outward and measures. Yet the underlying impulse remains the same: to seek, to understand, and to locate ourselves within the vast theater of existence. Ancient knowledge also demonstrates the interplay between observation and imagination. Stars guided practical tasks, agriculture, navigation, ritual, but also inspired philosophical and spiritual speculation. Contrast this duality with modern astrophysics. Observation produces data, but interpretation involves imagination, hypothesis, and speculation. Whether in temples, ziggurats, or infrared spectra, humans navigate the tension between measurable reality and the mysterious unknown. In this sense, Webb continues a dialogue begun thousands of years ago, linking empirical study with philosophical reflection. Finally, contemplating ancient civilizations in the context of cosmic observation underscores the universality of curiosity. Despite cultural, temporal, and technological differences, humans have consistently sought connection with the cosmos. Contrast the grandeur and immensity of galaxies with the intimacy of human observation, philosophy, and myth-making. The telescopes of today, the myths of yesterday, and the stories etched in stone and memory all participate in the same quest to understand the universe and our place within it. As we move from this section toward the concluding reflections, the narrative is clear. Webb reveals the cosmos in unprecedented detail. Yet the human desire to comprehend, to connect, and to find meaning mirrors the efforts of our ancestors. The telescope extends sight. Mythology and philosophy extend understanding. Contrast data with story, measurement with imagination, and find continuity in the pursuit of cosmic knowledge. The stage is set for the final reflections on consciousness, existence, and the boundless mystery of reality itself. As we ascend from the realms of ancient civilizations and cosmic observations, a profound question emerges. What is the role of consciousness in this vast, unfathomable universe? Webb reveals galaxies forming in the early epochs of time, capturing light that has traveled billions of years. Yet, for all this objective measurement, the act of observation itself introduces a subtle but profound implication. The universe, in a very real sense, is experienced through consciousness. Contrast the silent, cold expanse of space with the warmth and awareness of the human mind. The observer who interprets, contextualizes, and finds meaning in what is seen. Modern physics provides a framework for this interplay. Quantum theory, with its observer-dependent phenomena, hints that the act of perceiving can influence reality. In experiments with particles, waves, and entangled systems, observation collapses probabilities into measurable outcomes. Contrast this with the classical understanding of space and time as fixed, objective backdrops. Here, at the intersection of perception and reality, we find the cinematic theater of consciousness, an arena where matter, energy, and awareness intersect, shaping not only what is known but what can be known. Philosophers have long speculated on this relationship. From the ancient Greeks to Eastern mystics, Consciousness has been seen not as a passive observer, but as a participant in the unfolding of reality. Contrast the rigorous methods of astrophysics with the introspective inquiry of philosophy. One relies on measurement, spectra, and empirical validation. The other on introspection, meditation, and conceptual frameworks. Yet both converge on a single insight. The universe is not merely external. It is also internal, mirrored in the mind that contemplates it. Consider time and space themselves. From the perspective of classical physics, these dimensions are independent, flowing uniformly and objectively. Yet relativity demonstrates that time is not fixed, but relative, warped by gravity and motion. Quantum mechanics complicates this further, suggesting that on fundamental scales, causality is probabilistic, and events may exist in superposition. Contrast these findings with human perception. Our consciousness experiences time linearly, sequentially, and subjectively. In this gap between cosmic reality and human experience lies a tension, a space where awe, reflection, and existential inquiry flourish. Mystical traditions across cultures have long explored similar terrain. In Vedanta, consciousness is the ground of all experience, the thread connecting the self to the cosmos. In Taoism, awareness flows with the rhythms of nature, unifying the observer and observing. Contrast these interpretations with materialist frameworks that view consciousness as a byproduct of neural activity. Webb measures galaxies and infrared light objectively, yet the human mind cannot help but imbue these observations with wonder, narrative, and meaning. The theater of the cosmos is incomplete without the presence of an observer capable of apprehending it. The implications extend beyond philosophy and physics into the personal realm. When we look at the stars, we are confronted with our own finitude. Contrast the ephemeral span of a human life with the billions of years it has taken light to reach our eyes. In this confrontation with time and scale, consciousness serves both as witness and interpreter. We marvel, we question, and we seek to find patterns, connections, and significance. In doing so, the act of observation itself becomes a bridge between human experience and cosmic reality. Our perception is further challenged by the discoveries Webb brings forth. Galaxies forming sooner than expected, stars in configurations that defy current models, and hints of structures that push the boundaries of imagination, all of these confront the mind with the unknown. Contrast this empirical certainty with the interpretive imagination of the human observer. The telescope supplies data, but consciousness frames it, asks questions, and situates it within broader narratives of existence. The universe is both revealed and interpreted, objectively measured, yet subjectively understood. The observer effect in quantum mechanics serves as a metaphor for human experience on a cosmic scale. Just as measurement influences outcomes in the subatomic realm, so too does perception shape our understanding of reality. Contrast the independence of galaxies billions of light years away with the participatory nature of awareness. While stars and galaxies evolve regardless of our scrutiny, the comprehension and meaning we derive depend entirely on conscious engagement. The cosmos exists, yet it becomes meaningful only when it intersects with awareness. Cinematic reflection deepens when considering consciousness as a bridge across scales. Within the neurons of a brain, quantum processes may contribute to awareness, decision-making, and perception. Across billions of light years, photons traverse the universe, carrying information about events long past. Contrast the microcosm of thought with the macrocosm of cosmic history. In both, patterns emerge, order manifests, and the interplay of structure and uncertainty creates a dynamic narrative. Webb's observations and human perception together narrate a story that spans both the infinitesimal and the infinite. Philosophical speculation invites further contemplation. If consciousness interacts with reality, even subtly, then human awareness is not merely a passive witness, but an active participant in the unfolding of the cosmos. Contrast this with deterministic models of the universe, where matter and energy follow immutable laws. Here, the boundary between observer and observed begins to blur. The universe, vast and indifferent, is also relational. Its significance, meaning, and beauty emerge in dialogue with those capable of apprehending it. Art, literature, and mythology have long explored this participatory nature of consciousness. Starry nights, epic tales, and cosmological myths encode human awareness of the universe's grandeur. Contrast the poetic with the empirical. Webb's infrared data reveals light, chemical composition, and structural formation. Yet the mind translates this information into narrative, awe, and existential reflection. The cinematic experience arises not solely from what is observed, but from the interplay between observation, comprehension, and imagination. As we confront the potential for extraterrestrial life, consciousness becomes even more central. What does it mean to encounter intelligence beyond our own? Contrast the materialist view life as biochemical machinery with broader, philosophical perspectives that consider awareness, creativity, and subjective experience. Webb's discoveries may reveal environments capable of supporting life, but human consciousness frames these possibilities, imagines interactions, and anticipates the profound ethical and existential consequences. Observation is inseparable from interpretation. Data becomes meaningful only when processed through awareness that the act of looking itself carries profound consequences. Each photon collected, each spectrum analyzed, each galaxy imaged is filtered through the lens of human understanding. Contrast the objective mechanisms of detection with the subjective processes of comprehension. The telescope delivers raw information, yet the mind constructs narrative, meaning, and context. The theater of the universe is vast, but consciousness provides the stage, script, and audience simultaneously. In this sense, the cosmos is incomplete without engagement from minds capable of wonder. Consider the continuity between past, present, and future in the context of consciousness. The photons Webb detects departed from their sources billions of years ago, long before humans existed. Contrast this ancient origin with the immediate awareness of the observer. The mind bridges temporal gaps, connecting past light to present understanding. The universe's history becomes accessible through consciousness, allowing reflection on both cosmic evolution and personal existence. Time, perception, and reality converge in a cinematic interplay that evokes both humility and reverence. Mystical interpretations of consciousness offer further layers of insight. In some traditions, the self and the universe are inseparable, each reflecting the other. Contrast this with the reductionist approach of materialist science, which treats consciousness as emergent from physical processes alone. Webb measures photons and spectral lines, revealing galaxies and structures objectively. Yet human reflection transforms this data into a narrative of connection. The stars are distant, yet they resonate within, reminding us that awareness itself is a lens through which reality gains significance. Existential reflection intensifies when considering humanity's place in the universe. Consciousness allows us to grasp the immensity of space and time, yet also recognize our own transience. Contrast the permanence of stars and galaxies with the brevity of individual life. In this tension, all rises. We are simultaneously insignificant and central, fleeting yet capable of understanding the cosmos. Webb magnifies the scale, quantum mechanics refracts it, and consciousness synthesizes it into meaning, narrative, and reflection. The observer in the cosmic theater is not merely passive. Through imagination, interpretation, and inquiry, awareness shapes the questions we ask, the theories we construct, and the philosophical frameworks we embrace. Contrast the material universe, operating independently of our perception, with the experiential universe, emerging through cognition and contemplation. In this duality, science and philosophy, measurement and meditation converge to expand understanding and enrich the cinematic experience of reality. The interplay of consciousness and the universe also informs ethical and existential inquiry. Understanding the vastness of space, the potential multiplicity of life, and the fragility of planetary ecosystems evokes reflection on responsibility, stewardship, and purpose. Contrast empirical observation with reflective imagination. While data informs knowledge, consciousness shapes meaning, value, and action. Webb illuminates the cosmos. Awareness interprets it. Together, they create a narrative that is both intellectually rigorous and emotionally profound. Finally, the cinematic power of consciousness lies in its ability to unify perspectives across scales. From the quantum to the galactic, from ancient civilizations to contemporary science, from myth to mathematics, awareness bridges domains, rendering the universe intelligible, meaningful, and awe-inspiring. Contrast the objective immensity of cosmic phenomena with the subjective intimacy of perception. Human consciousness transforms photons into comprehension, history into narrative, and existence into reflection. Webb extends sight. Consciousness extends understanding. As this section draws to a close, viewers are invited to recognize their own participation in the cosmic theater. Observation is not passive. It is a form of engagement, a dialogue between mind and universe. Contrast the silent stars with the active awareness of the observer. Each reflection, each insight, each question shapes the way the universe is apprehended and appreciated. In this cinematic interplay, the universe is not only seen, it is experienced, interpreted, and cherished. Consciousness and cosmos converge, inviting both scientific inquiry and profound existential wonder. In contemplating our place in the universe, the audience is challenged to ask, what is the nature of reality if observation is inseparable from existence? How does awareness transform data into meaning, light into understanding, and space into narrative? Webb's discoveries, quantum theory, and the reflections of philosophy and mysticism coalesce to suggest a profound truth. The universe is both external and internal, measurable and ineffable, observed and participatory. Consciousness is the lens, the interpreter, and the stage upon which the cosmic drama unfolds. As we reach the culmination of this journey, it becomes clear that the cosmos is not a static stage, but a living, evolving narrative. And we humans are both spectators and participants. The James Webb Space Telescope has pierced the veil of deep space, capturing light that traveled billions of years, unveiling galaxies in their infancy, revealing structures that defy expectation. Yet, for all the data and imagery, we confront a profound contrast. What we know is immense, measurable, and elegant, while what remains unknowable stretches beyond imagination, into the realms of mystery and speculation. This tension between knowledge and uncertainty defines the essence of our quest, bridging science and philosophy, observation and contemplation. Consider the galaxies Webb has revealed, unexpectedly mature, complex, and diverse. Theories of cosmic evolution, once thought robust, now face challenges as these distant structures suggest processes that defy conventional timelines. Contrast the certainty of light's travel with the ambiguity of interpretation. Each photon tells a story, yet the full narrative remains elusive. In this interplay, we are reminded that observation is only part of understanding. The universe is far more intricate than our models, more intricate than our imagination. Scientific inquiry offers a framework, but it is never the totality of truth. Humanity's reflections on the cosmos, from ancient civilizations to contemporary astrophysics, underscore a persistent truth. The more we discover, the more questions emerge. Contrast the precision of Webb's instruments with the ineffable, poetic qualities of the night sky that have inspired mythology, philosophy, and art for millennia. The telescope measures wavelength, intensity, and structure. Our consciousness interprets meaning, significance, and beauty. These dual perspectives, empirical and experiential, are not contradictory but complementary. One quantifies, the other contemplates, and together they reveal the full tapestry of cosmic wonder. We are also reminded of our place in the temporal vastness of the universe. Light captured today began its journey billions of years ago, long before the Earth formed, before life emerged, before civilizations existed. Contrast this enormity with our fleeting existence. Individual lives, species, and even civilizations are transient on the cosmic scale. Yet, paradoxically, this very transience amplifies the significance of consciousness, reflection, and curiosity. In the brief span of awareness, humans have gazed upward, measured the heavens, decoded ancient light, and glimpsed truths that would have been inconceivable mere centuries ago. Our capacity to perceive, interpret, and aspire confers profound significance within the vast cosmic theater. Philosophical reflection deepens when we acknowledge the limitations of knowledge. Webb presents photons and spectra. We interpret meaning. Contrast objective measurement with subjective comprehension, and we recognize that truth is never fully captured by data alone. Mysteries persist. What drives galaxy formation beyond our models? What forms might life take in distant worlds? How does consciousness emerge, and what role does it play in the architecture of reality? Each answer unveils new questions, and in this perpetual unfolding, the journey becomes as significant as the discoveries themselves. The interplay of observation and interpretation extends beyond science. Ancient myths, philosophical inquiry, and contemporary speculation all seek to reconcile the observable universe with the human experience of awe, wonder, and existential contemplation. Contrast the empirical with the imaginative. One constructs models, the other crafts meaning. Both, however, are acts of engagement. By exploring galaxies beyond human reach, we are simultaneously exploring the depths of our own awareness, confronting the sublime, and situating ourselves within a continuum that spans time, space, and consciousness. Cosmic reflection also invites humility. The scale of the universe, the age of galaxies, and the complexity of physical laws dwarf human concerns, yet paradoxically illuminate human potential. Contrast our minuteness with our cognitive abilities. We measure, interpret, theorize, and imagine. We convert faint infrared light into insight, photons into understanding, the distant past into knowledge. In this contrast lies both awe and empowerment, recognition of limits, coupled with the remarkable capacity to transcend them through curiosity, creativity, and reason. Speculation naturally follows observation. Webb's revelations hint at phenomena that challenge our deepest assumptions. Galaxies forming faster than expected, star clusters with unexpected properties, potential signals of exotic processes. Contrast rigorous scientific frameworks with the imaginative horizons they provoke. Here, speculation is not idle fantasy. It is the natural extension of inquiry, a bridge from what is observed to what is conceivable. Science measures the universe. Philosophy and imagination interpret its implications for reality, consciousness, and existence itself. This reflection extends to the search for life beyond Earth. Webb illuminates planets, atmospheres, and molecular signatures. Yet the ultimate question, are we alone, remains unresolved. Contrast the empirical data with the existential significance of potential discovery. Evidence of life elsewhere would reshape our understanding of biology, consciousness, and our role in the cosmos. Even without confirmation, the search itself prompts profound contemplation. if life exists in forms beyond comprehension? What does this reveal about the universality of consciousness, adaptation, and intelligence? Observation ignites imagination. Speculation inspires philosophy. The journey from observation to reflection also encompasses the human experience of time. Light traveling billions of years bridges epochs, linking cosmic infancy to present awareness. Contrast the longevity of galaxies with the brevity of civilizations, individual lives, and even planetary lifespans. Yet, within consciousness, this temporal disparity dissolves. We perceive, contextualize, and derive meaning across these vast scales. The telescope extends sight. Reflection extends significance. In this cinematic interplay, the cosmos becomes not only a subject of measurement, but a canvas for contemplation, narrative, and existential inquiry. Ultimately, the truth of the universe is dual, part measurable, part mysterious. Webb provides empirical insight into structure, formation, and evolution. Human consciousness interprets these revelations, asking questions that exceed empirical boundaries. Contrast certainty with uncertainty, knowledge with mystery. In this liminal space, all flourishes. We recognize the boundaries of understanding, yet we are inspired by the infinite possibilities beyond. The universe is revealed, yet it remains elusive, inviting perpetual exploration, wonder, and reflection. The cinematic journey concludes with a synthesis of discovery and introspection. Webb's light captures cosmic history. Philosophical reflection situates humanity within it. Contrast observable phenomena with the unknowable depths of existence, consciousness, and potentiality. The telescope illuminates. The mind interprets. The facts of galaxies, stars, and planets intersect with questions of purpose, significance, and the nature of reality. In this convergence, viewers are invited to embrace both knowledge and mystery, curiosity and humility. As we step back from the details of distant galaxies, from infrared spectra to cosmic timelines, the narrative resolves into contemplation. What is the ultimate truth? Perhaps it is not fully knowable. Perhaps it resides in the interplay of observation and imagination, measurement and reflection, consciousness and cosmos. Contrast the cold precision of data with the warmth of human awareness. One captures reality, the other grants it meaning. Together, they compose a cinematic meditation on existence itself. In the final reflection, we recognize our dual role as explorers and interpreters. The universe is vast, ancient, and often incomprehensible. Webb extends our vision across time and space. Consciousness translates perception into understanding, context, and wonder. Contrast the scale of galaxies with the intimate scale of human thought, and we perceive a profound symmetry. The mind reaches outward, the cosmos unfolds inward, and both participate in an eternal dialogue. Observation is not passive. It is engagement, interpretation, and connection. Thus, the ultimate revelation is both external and internal. Webb reveals photons and structures. We reveal meaning and significance. Contrast knowledge with mystery, certainty with speculation, and we glimpse the profound balance at the heart of existence. The universe is both a stage and a mirror, showing not only what is but reflecting who we are. Our search for understanding is, in essence, a search for ourselves, our consciousness, our curiosity, and our capacity to be moved by the infinite. And so, as the journey concludes, the audience is left in a cinematic suspension of awe. The facts revealed by Webb are astounding. The mysteries that remain are sublime. Contrast these realms and recognize that both are essential. One anchors us in reality. The other elevates us into contemplation. Between the measurable and the ineffable lies the beauty of inquiry, the poetry of existence, and the enduring human quest to understand the cosmos. The final thought echoes across time and space. The universe is not merely out there, distant and detached. It is within us, through our perception, interpretation, and reflection. The telescope unveils what is. Consciousness imbues it with significance. Contrast the objective grandeur of galaxies with the subjective depth of awareness, and we perceive a truth that is both scientific and existential. Reality is not only observed, it is experienced. It is measured and felt, quantified and contemplated, known and mysterious. In this eternal interplay between discovery and reflection, we find our place. The cosmic theater is vast, yet consciousness allows us entry, participation, and wonder. Webb has extended sight. Humanity has extended understanding. Contrast the finite with the infinite, the transient with the enduring, the observed with the observer. In this duality lies both humility and empowerment, wonder and comprehension, fact and mystery. The journey concludes, yet inquiry continues, echoing the ceaseless curiosity that defines our species. As the screen of the mind fades to the vast panorama of the universe, a final meditation emerges. The cosmos is immense. The truths revealed are profound, and the mysteries that remain are eternal. Contrast the certainty of light captured by Webb with the boundless scope of what is not yet known. Both are essential. Both inspire. In this cinematic, contemplative pause, viewers are invited to reflect, to dream, and to recognize that their consciousness is inseparable from the cosmic story. The journey from observation to understanding, from light to meaning, from data to awe, is ongoing. It is the essence of being human in a universe that is as mysterious as it is magnificent. And so, we close not with final answers, but with reflection. The telescope has shown us galaxies, stars, and light beyond imagining. Philosophy and consciousness have reminded us of our place, our perspective, and our wonder. Contrast revealed and unrevealed, known and unknowable, and we arrive at a cinematic truth. The universe is at once intelligible and inscrutable, observed and observer, fact and poetry. Our quest continues, propelled by curiosity, guided by consciousness, and inspired by the infinite expanse that surrounds and permeates us.